Hi everyone, and welcome to Creativa Solutions. I'm Anthony. Today we're going to be looking at another past paper, this time for the May-June 2015 exam for the DSC1630 module. Alright, so to start off, I've got a third-party disclaimer here. The material in this video may include information, products, or services by third parties. Third-party materials comprise of the products and opinions expressed by their owners. As such, I do not assume responsibility or liability for any third-party materials or opinions. I cannot guarantee the accuracy of the information contained in the third-party material. Presentation of such third-party material is simply used as a tool for assisting viewers with answering questions for educational purposes. All trademarks appearing in this guide are the property of their respective owners. Alright, you're currently watching this video, which is going to show you exactly how to approach the exam past paper. I'm hoping with more practice and with more of these videos that you've been watching, it should become easier and easier to approach any question looking at time value of money comprising of DSC 1630. Right, so I'll show you what to look for, I'll show you how to answer the questions, and also there's lots of more content and resources available on the website www.creativasolutions.com. Follow us on Twitter at creativa_s and watch our YouTube channel for more support. Alright guys, good luck with your studies, and let's get started with the first past paper. Alright, so a good exam technique is obviously to look at the time allocation. You've got 2 hours here, the paper's out of 100, and this is the May-June 2015 paper. DSC 1630 is looking at the introductory financial mathematics, and we're going to be looking at a lot of the calculator work. Okay, so I'm hoping by now you've got a financial calculator that you're familiar with. There are different options available. Cashier is the one that I prefer. There's also an HP and there's a Sharp as well. It doesn't matter which calculator you're utilizing, as long as you're comfortable using those calculators, that'll be great. Alright, so let's start off with the first question. Question number 1 says, suppose you need $12,300 in 2.5 years' time to pay for a new washing machine. You can earn 11% simple interest per year on your money in the bank. There's the keyword, 11% simple interest. Okay, remember, I'm looking for keywords in every question to make the calculation easier for myself when I then approach it. Okay, so in the exam, I've got a formula sheet. Right, so I'm going to go to the formula sheet and I'm going to look for the correct equation which utilizes simple interest. Okay, there's the equation for simple interest. So I'm going to take that equation and I'm going to be using it for this particular question. Right, future value, present value, R and T. Okay, I know that I'm going to be needing 12,300 in 2.5 years' time. Alright, I know the 2.5 years time is the number of years, okay, in terms of N. I know I have 11% simple interest, and that's per year. Alright, and I'm going to then solve for PV. Okay, so take the bracket to the left, solve for PV, and on the calculator, obviously you type that in normally manually on the financial calculator or scientific, and you'll get an answer of okay, 9647, option number 3. Right, question 2 says, Pam took a student loan, took out a student loan, okay, she applied for a student loan to help her pay for her last years of college and received 12,600. She had to repay 15,000 after 2 years. The simple discount applicable is, again, look for a keyword for me. The keyword that should be standing out for you as well is simple discount rate. Right, so again, go to your formula sheet and locate the correct equation. Discount rate requires that formula. Alright, so now I've got the correct equation. I go back to the question and I substitute what I know. Okay, we know she received 12,600 today and she'll pay that back in 2 years. Okay, obviously interest is applicable and the repayment is 15,000. Right, so substitute and then solve. Right, remember guys, in this particular question, I'm looking for what? I'm looking for D. Right, so I'm taking the 15 across. Okay, then 2D equals 1 minus 0.48. Right, 0.08 or 8%. Option number 4. Okay guys, question 3. We have Jerome invested 4,500 at 7% interest compounded quarterly. Keyword here, compounded quarterly. I4. The number of years he has to wait for this account to grow to that is, right, so I'm looking for N obviously. Okay, the I here was 7% compounded quarterly. And I'm solving for N. Right, just remember the calculator will get confused if you put in a positive for both of those amounts. Remember, we need to insert cash flow, positive and negative, i.e. inflows and outflows. Right, so looking at this, I'm going to obviously make the investment an outflow because you would invest and then you would receive an amount later in the form of an inflow. Okay, so he invested minus 4,500 and we'll get back that in the future. Right, if I solve for N, N comes out as 15,999. Okay, remember, this is quarters. Why is it quarters? Well, I inserted I4. So if I insert I4, I'll get N in quarters. Right, so if I divide that, I'm going to get the number of years. 16 divided by 4 gives me 4. Right, remember the question said the number of years, not the number of quarters. Right, so 4 years. Alright, question 4 guys. When you see a long question like this, okay, you should be thinking timeline, timeline, timeline. Okay, the reason for that is if you just look at the question, you know there's going to be a lot of different cash flows over a period of time. Right, so in question 4 they say to pay off a loan of 7 due now and a loan of 2,000 due in 14 months time. Okay, so okay, so what are those two amounts? Those two amounts are loans. Right, Rajesh agrees to make 3 payments in 2, 5 and 10 months time respectively. The second payment is to be double the first and the third payment is to be triple the first. Okay, so 2, 5 and 10. Okay, so X there, that's one payment, double the payment, and triple the payment. Right, so again, what are those? Those are payments. Okay, those payments are going to reduce the loan. What else do I have? Okay, well, they want to know what is the size of the payment at month 5. Okay, that's important. So they want to know what this payment is at month 5. We know it's twice the size of X. Okay, we know interest is compounded monthly, so that's I-12. Okay, so important here, theory, guys. Remember, all those amounts need to be at the same point in time. It doesn't matter where you take those amounts as long as you're taking them all to the same point. Right, so I'm going to be taking all these amounts back to time 0. Okay, so I'm going to be looking at amounts at one point in time in this particular question. I'm going to focus on time 0. Okay, so take everything to one point in time. Okay, so obviously my loans must equal my repayments. Okay, because I'm going to be paying off this loan over a series of time, okay, and obviously the loan needs to be paid off, so the value of the loan will equal the value of the repayments. Alright, so loans equal repayments. I want everything to be at the same point in time, so I'm happy with the 7,000 being where it is. The only thing I need to do with the 2,000 is take it back in time. Okay, the ratio was 16% compounded monthly. To the power, I'm taking it back minus 14. Okay, remember, that's the amount over there. I'm taking that back in time to time 0. Alright, and that's going to be equal to my repayments. Okay, so obviously take all those loans back to one point in time. Then do the same thing for the repayments. Alright, so I'm going to be taking X back to time 0. I'm going to take 2x back 5 periods, and I'm going to take 3x back 10 periods. Okay, so I'm taking all those amounts back in time to time 0 because repayments must equal the loans. Right, so once I've got that, I'm then going to take all those numbers in brackets, okay, and I'm going to make a figure, a number. Type that into the calculator, and I'll have an equation with x. Okay, I'll have 3 x's actually. Okay, and then I'll then solve for x. Okay, so if you take what I have in green and what I have in red and you solve for that on your financial calculator or normal scientific, you're going to get those figures. Right, I'm then going to add up all the coefficients of x, obviously to get one amount, and then I'll solve for x. Right, and if you solve for x, you get that. Okay, but remember the question wanted the payment here. Okay, at time 5. Alright, so if I'm looking at time 5, I'm going to have to multiply this by 2 to get the payment at time 5. Right, which is 3164, option number 3. Okay guys, question number 5. We've got 5 and 6 relating to the following situation. Nico is moving to Cape Town at the end of the year. He deposited 360,000 into an account that earns 7.91% per annum compounded monthly on 8 January. He intends to withdraw his money on the 21st of November of the same year, and he's used a down payment on the house. Okay, the interest is calculated on the first day of each month. Okay, first day of each month, right? 8th Jan, 21 November. We know we're going to have to be calculating dates and times here. Alright, so what is question 5 asking you to do? The simple interest is used for odd periods. Okay, so there's your odd period calculation question. Make sure you can draw the diagram correctly. The key with any odd period question is take all that English in the question and convert it into a diagram. Okay, a timeline that shows you exactly where all the cash flows are and what the periods are between dates. Okay, so let's recreate a timeline after having read that information. Right, so those are some dates that I've read in the question, 8 Jan to Feb. Obviously, this is simple interest, and this would be compound interest. Right, why? Because this is an odd period calculation. So odd period calculations require you to use simple interest, compound interest, and simple interest. Okay, so 3 calculations that we need to do separately. First step is obviously to count the number of days between 8 Jan and 1st Feb, 1 November to 21st November. Right, so if you don't have a calculator that can work that out for you, you are going to need to use this table. Okay, so if I'll just show you how to use the table once, and then you'll obviously practice using the table. Okay, I've got a calculator. The CAS is actually quite good because you can work out the number of days between 2 dates. Unfortunately, on the HP and the Sharp, it lacks that feature. Okay, all right, so 1st Feb to 8 Jan. Okay, so I'm looking for 1st Feb. There's 1st Feb, 32. Okay, I'm looking for 8 Jan. There's 8 Jan, 8. Okay, so what's 32 minus 8? 24. Okay, and you do the same thing here. 20 days. Alright, so step 1, simple interest calculation. Okay, take the amount that you started with, which was 360,000, and move that to 1st Feb. Right, so that's the first answer that I get. That's the future value using simple interest. I'm now going to take that forward using compound interest. Alright, the number of months, obviously from Feb to November, is 9 months. Okay guys, and that's the future value using compound interest. Okay, now what do I do? Final step, step 3. Simple interest again. And I'm going to be taking this amount forward. Right, and I get that answer. Option number 5. Okay, that's question 5. Okay, if we look at 6, fractional compounding is used for the whole period. Okay, so if it's fractional compounding, I'm going to need a number of days perhaps. Okay, if you prefer using I365, okay, you'd have to then do a conversion, or you would have to work out how many days you actually have from the one period to the next. Okay, so let's work it out using, let's say, the total days. Okay, so from 8 Jan to 21st November, if you do that calculation, you're going to get 317 days. Right, I'm then going to need to convert I12 I365. Right, and I'm going to be using my equivalent rates formula. Okay, so I've shown you the equivalent rates formula before, so this should be okay hopefully by now. Right, I'll write down the equation Im to the m equals 1 plus In to the n. Okay, what am I looking for? I'm looking for I365. What did I have in the question? I12. Okay, so if I get rid of this bracket, I'm going to divide the exponent by 365. Okay, and then I'll subtract 1 to get I365. Okay, so I12 okay, was that 0.791 divided by 12. Alright, so solve for I365 using your financial calculator or scientific, and you get an answer of %. Alright, so now you've got all the variables. I'm going to be taking this as my I. I've got my N. I just need a present value. Then solve for future value, and if you solve for a future value, you're going to get alright, 58. Okay, and looking at our options here, option 2 looks great. Alright guys, Question number 7. Alright, so question 7 is talking about a carpenter opening a savings account on 8 Jan at a local bank where simple interest is 24% per year. Again, there's the keyword, simple interest. He deposited 5 on opening his account on 8 Jan. On 15 Jan, he deposited a further 4. 25th Jan, he deposited a further 100. The total interest to the nearest rand on this account on 1st Feb is equal to. Okay, so again, I would draw a timeline here just to make it look a bit easier in terms of interpretation. Read all the dates and draw a little timeline. Right, I know the guy deposited 500 here, 400 there, and 100 here. Okay, and what am I going to be doing? I'm going to be taking all those amounts forward. Okay, so the 100 forward, the 400 forward, and the 500 forward. Okay, remember they told you this was simple interest, so I'm going to be using that equation for all of those calculations. Okay, and I'm looking for what? The total interest. Okay, so I don't need the principal, I just need the interest. Okay, so 1 plus, what is the rate here? 24%. Okay, the number of days for this one is, let's have a look, it's 100, 7 days. Okay. Alright, for 7 days. Alright, these arrows actually need to go the other way around. Okay, there we go. Alright, so I took the 500 forward, then the 400 forward, then the 100 forward. Okay, remember I'm looking at the interest. I'm not worried about the 100, the 400, and the 100. I'm just looking at those 7 Rand 80. Okay, so minus 500, minus 400, minus 100 to get the interest. Okay, and if I sum up all of that, I get that answer, which is representing what? The total interest. 13 Rand would have been the nearest Rand. Okay, question number 7. Okay guys, let's have a look at number 8. Okay, so number 8 says, if an investment of 2,000 accumulates to 2,800 at a simple interest rate of 9% per annum, then the length of time in years of the investment is given by. Okay, so when I see this simple interest, immediately I write down the equation. Okay, we know what the equation is. S 1 plus RT. Okay, so I'm investing 2,000 and I'm going to accumulate 2,800. I'm working out the time. Okay, so take the 2,000 to the left. Okay, I'll then have 1 plus there, so I need to minus the 1. 0.90. Alright, and then obviously I'm going to have to take this whole amount, okay, and divide it by 0.09 in order to get T. Okay, so which option is correct here? Option number they want to know the length of time in years of the investment is given by. It would be 2,800, so that's right, 2,800 over 2,000, okay, minus 1, right, over 0.09. Okay, 0.09 isn't there. Right, so we need to work out what is 0.09. 100 divided by 9. Okay, so let me do it this way. 1 divided by 0.09 is what? Let's check. 1 divided by 0.09 is 1.11. Okay, 11,11. Right, so 100 over 9 is 0.01. Okay, or 1 over. Alright, so option 1 is definitely correct for this one. Alright, question 9. In 3 years' time, Paula is going to need 145 to pay for a vacation. She immediately starts to make monthly deposits. There's the key, the deposit, so this is the annuity, and immediately that's begin mode. Okay, earning 11.5% interest, compounded monthly, so months and months. They want to know what the payment is. Okay, so nice and simple, solve for the payment. Identify the variables, then solve. Remember to change your calculator from end mode to begin. The I here was 11.05%. Right, and if you solve for the payment, I'm going to get 3384, option number 1. Alright, question number 10, the equation for the present value of a bond. Okay, so this is a bond calculation. Right, remember, good exam technique in the exam would be to maybe leave the bond questions for the end. Okay, remember, no one is forcing you to do question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through to question number 30. Right, if you want to jump around and do different questions, that's totally up to you. Okay, good exam technique would be to do the easiest questions that you're comfortable with and then come back to the more difficult. Okay, so if you're not so comfortable with the bonds, skip it. Rather do all the questions, make sure you pass the exam first and then get your distinction after having done all the easier questions, okay, or the questions that you're more confident with. Alright, so here I'm looking at what? Bonds. Okay, and I've got a formula, okay, which is look at the present value of the coupons, that's the coupons, and that's the face value, and I'm discounting those back in time. Alright, so the fraction of the year to be discounted back is that one there, and they want to know what is the accrued interest. Okay, so nice question. All you're going to have to do is determine, is this cum or is this x? Okay, well, if it's 74 days, this is cum. Right, so if it's cum, I'm going to be utilizing the formula for cum interest, which is this one over there. Alright, so accrued interest is going to equal H minus R over 365. Okay, remember my coupon here is, alright, so you've got a coupon there of 7,35, but remember, you've got a divide by 2 here. So what does that mean? That means these coupons are half yearly. So to get the annual coupon, I'm going to have to times it by 2. Right, and that's my accrued interest. Option number 2. Alright guys, question number 11. A principal of 70 is invested for 4 years. Find the difference in the future value if the interest is 6% compounded quarterly compared to continuous compounding. Okay, so we're looking at the difference between the future values. Alright, so future value using compound interest quarterly versus future value using compound interest continuously. Alright, so the one requires a formula. There's the equation for continuous compounding. I take that straight from my formula sheets and I write that down. Okay, obviously the first one you'd be able to work out using your financial calculator. Just identify the correct variables. Why 4 times 4? I'm using quarters and they talked about 4 years here. Right, so obviously continuous compounding versus compounded quarterly. Okay, we would expect the continuous compounding to have a bigger answer than the quarterly compounding. Right, and those are the two answers you get. Obviously the answer is looking for the difference. So the one minus the other gives you an answer of okay, 158.45. Option number 5. Alright, question number 12, guys. 12 is looking at Brian borrowing money that must be repaid in 9 payments. Okay, the first 4 payments of 2,000 each are paid at the beginning of each year. Okay, that's key. When you see beginning of each year, you know what mode to change your calculator into. Begin mode. Thereafter, 5 payments of 5,000 each are paid at the end of each year. Okay, so you've got beginning and you've got end here, and you've got 6.85 per year. They want to know what the present value is of these payments. Right, so a good idea would be to draw a timeline. Right, and let's put all the cash flows. Okay, so 2,000 beginning of each year. And then 5,000 at the end of each year. Okay, how many? 5. Alright, so we don't need time 10. Okay, and then you've got begin mode and you've got end mode. Okay, so I'm first going to work out the present value of this annuity. Right, if I solve for the PV comes out to okay, now what do I do with that? Well, I need to take it back in time. Okay, so obviously my future value is going to be that. Right, and that's going to be my present value. Alright, so now I know what the present value is of this annuity today. Okay, there's one of my answers. Right, I still need to add the present value of all of that. Okay, using begin mode. Alright, so my final answer is going to be the two amounts added together. This plus that gives me that answer. Option number 2. Okay. Question number 13. The present value of payments of 1,100 per month for 8 years at an interest rate of that per annum is compounded. They want to know what it approximately equals. Okay, it's present value of all those payments. Okay, remember I was given per month here and I was given compounded quarterly. Okay, so I've got I4 but I've got monthly payments. So when I start to do I4, I need to convert it to I12 first. Once I've got I12, then everything is aligned. Okay, per month and monthly payments. Right, so the payments here were the most important. Okay, so make sure you convert. Okay, we did a conversion earlier, so I'm just going to write down the equation for you. Right, so 1 plus Right, and then solve for present value. Okay, you've got the payment, you've got the N, you've got the I now. Remember, I'm using I-12. Why am I using I-12? It's because of this. Per month. Okay, so I need to use the right I with the correct monthly payments. Okay, and that's the present value that I'm going to be getting. 65,965, which if you round off to the nearest rand, would be that answer over there. Okay, now option number 3. 3, option 965. Sorry, 965. I'm reading the options incorrectly. It should be option 4. Okay, 65965. 65965, yeah, that's the right one. Alright guys, question number 14. Eddie took out an endowment policy that will pay out in 15 years' time. So his first annual payment is that, where after it increased yearly by. Okay, so notice, as soon as I read that, I already know this is what? A growing annuity. Okay, so all I need to do is go to the formula sheet and pull the equation that I need in order to calculate a growing annuity. There's the equation. Take the equation through to your working. Right, and then do the calculation. Right, remember, identify the R, which is the payment, the Q, which is the increase, the I is the rate, and the N is the time. Okay, remember, with a question like this, you can actually calculate this separately on your financial calculator. Right, all you're going to have to do though is first work out what that amount is separate. Okay, so if I work that out separately, my payment is going to be okay, and what is that representing? The payment. Right, then I just put in my N and my I. And I solve for my future value. Right, if I solve for my future value, I'm going to get an answer of okay. Right, then what is my last step? Well, my last step is to obviously look at this, the N and the Q minus I. Okay, because I know this is going to be occurring over 15 years, and I haven't looked at that bit. Okay, so this bit over here, okay, less that from that. Right, so final answer would be this minus okay, gives me that answer. Right, option number 5. Alright, question 15, guys. Ronaldo was awarded an amount from the Football Association as compensation for injury sustained during the World Cup game. He chose to receive 18,900 per month indefinitely. Keyword here, indefinitely. They've even italicsed it. Okay, so you know this is a perpetuity. Right, they want to know the amount awarded to him equal. If money is worth that compounded monthly, then the amount awarded to him equals. Okay, so they want to know what is the actual amount worth in terms of his compensation. Right, so PV equals divided by I12. What is the I here? 9.95 compounded monthly. Uh, 995 divided by 12. Okay, and I get that answer over there, which is option number 2. Alright guys, question number 16. Suppose Chase can afford monthly payments of that and has obtained a 3-year loan of that. The loan is financed 12.5% interest compounded monthly. Right, the interest due at the end of the first month. Okay, so this is an amortization type of question. Okay, you're going to have to use the amort button or function on the financial calculator. Okay, that's the key. Right, just identify the variables, substitute and solve. Alright, so n equals 3 times 12. Okay, you can see that in the question. We read it. They spoke about different months, right? They're looking at 3 years in terms of the loan, and the payments are monthly. Okay, so I'm solving for PV. Right, we know what the PV is supposed to be. Okay, 44240,35. But remember, I need all those variables in the calculator first before I can work out the actual amortization. Okay, and if I solve for the interest, that's what they want, the interest due at the end of the first month. So it'll be 1, 1 on your calculator. Depending on what type of calculator you're using, if it's the HP, you have to go second function, amort, alright, to get the 1, 1. Okay, when you've got the 1, 1, then you just press equals to read the different figures. If you've got the Casio or the Sharp, you're going to have to change your P1 and P2 on your respective calculators, okay, to make it P1 and P2. Come on, there's the 2. Okay, to make it 1 and 1, and then you're looking for the I and T, the interest. Okay, for this particular one. Okay, the interest, right? And they also want the principal repaid after the first month. Okay, which is the PRN. Okay, so on your calculator, solve for the interest and in the principal. That's 16 and that's 17. Okay, interest comes out to and the principal comes out to, okay, and those are the amounts that you've got. Alright, so option 4 for that one, and 10, 19. Yep, that one. Okay. Right, so that was question 17. Question 18. Okay, a proposed investment of 130 is expected to generate the following revenues: 140 at the end of year 1, 140 at the end of year 2. Internal rate of return is what? Okay, so this is insert cash flows, solve for IRR. Okay, it's as simple as that. Just remember to use your cash flow function correctly. So you need to obviously consult your calculator in order to do that. Okay, and you should get an answer of after a while. The calculator takes a bit of time to get the answer. Okay, 20.29%, option number 3. Alright, you bought a house and managed to secure a loan for 790,000. Monthly payments of that, fixed interest of that, compounded monthly over a period of 20 years, and an average year of inflation. Okay, yearly inflation. Right, so when I see inflation, I know this is probably going to be a real cost of interest type calculation. Okay, they say then the real cost of the loan equals. Okay, that's exactly what they want. Alright, so you know from your theory that the real cost is present value at inflation less the cost. Alright, so the most difficult part of this particular question is obviously to get this, the present value at inflation. Alright, so in order to do that you need the variables. Okay, this is a 20-year loan. Okay, remember I'm using the inflation rate, which you read in the question was 9.2%. Right, that's the amount that I'm going to be using here as my I, because I'm looking at the present value based on inflation. Right, and the payment was given in the question as 9680. Right, if I solve for my PV, okay, I get that answer then. Right, then I need to less the 790,000, okay, to get an answer of okay, 270,749. Okay, option number 3. Okay, question number 20, guys. Right, project requires an initial investment guaranteed to yield 1,500 at the end of the first year, and then at the end of the second year, and then X at the end of the third year. Right, so when you see a question like that, you know this is an NPV type calculation, but it's a bit different because you need to interpret the actual cash flows. Right, so we need to remember the theory. Okay, the theory is so important. Why? Because you can't do this calculation if you don't know what NPV is equal to. NPV is equal to the present value of the future cash flows less your initial investment. Right, so did they give me the NPV in the question? Yes, they did. Okay, 838.18. Right, they also gave you the initial investment being 7,000. Alright, minus 7,000. Alright, so I can actually work this out in terms of an equation. My present value of my future cash flows would equal that. Right, then I'm going to have to be working out what is the third cash flow. Right, because remember, the present value of all my future cash flows must amount or equal this particular amount. Okay, the 7,838. Okay, comma 18. Right, so in order to do that calculation, I'm going to have to substitute what I know in this particular question. Okay, so what do I know? I know I'm going to get 1,500 at the end of the first year. Okay, so if I discount that back for 1 year, alright, that will give me one of the cash flows. Alright, I'm then going to have to discount all the others. Okay, so what other cash flows did I have? I had 2,500. Okay, and when did I get that? That was the end of the second year. And then the final cash flow, which is unknown, which is an X, okay, being taken back for 3 years. Alright, so all of this on the right of the equal sign is the present value of all those future cash flows. There's a future cash flow, there's a future cash flow, and there's a future cash flow. I don't know what those cash flows are. I only know what 2 of them are. I don't know what the third one is. Okay, and that's why I'm solving for this, which is my X. Okay, so I'm going to be taking those figures to the left, and I'm going to be working out an amount. Okay, equals that. Right, then the last step is obviously to take this bracket to the left and to solve for X. Okay, and if you solve for X, you get an answer of okay, which if you round off to 5,000, that would be your option. Okay. Nearest rand, option number 1. Okay, 21 says the profitability index is equal to, okay, so again, go to your formula sheet and take your profitability equation, write it down, then substitute and solve. Right, so they gave you the NPV and they gave you the initial investment. Take the one amount divided by the other amount and you get one of the options. Option number 3. Right, what is question 2 looking at? Well, modified IRR, there's the key. Okay, they've given you a system of cash flows there. They said money can be borrowed at 14.25 and investments can earn 8.27. Right, the future value of the inflows. Okay, so I've got the future value of the inflows. Remember, I need this equation, modified IRR. Okay, so there's my equation. Remember, the C stands for the future value of your inflows. Okay, so do I have that? Yes, I do. That's given in the question. Okay, so future values of the inflows was given the question as, there's the amounts. Okay, I need the present value of the outflows. Alright, so that's the question that I need to obviously answer. Okay, so I need to draw up my cash flow. So using Okay, how many do I have? 11. Okay, obviously I'm putting in what? These, the outflows. Okay, so an outflow occurs year 5 and year 7. Okay, so minus 70 and minus 80. Okay, insert the I. What was the I here? This was 14.25. And solve for your net present value. Okay, if I solve for NPV, I get negative 67. Alright, so all I need to do now is take this amount, substitute into this equation, okay, and solve. Alright, so my modified IRR comes out to okay, 9.72%. Option number 2. Okay, question 23. Alright, question 23 is a standard deviation question. So when you see questions like this, you should be jumping up and down and saying yes. Why? Well, they're easy. Okay, all you need to do is literally grab the calculator, insert those values into the calculator, press a button for the stats mode, and solve for the standard deviation. Right, if you do that, the calculator will give you an answer. Okay, you don't need a fancy financial calculator. Normal scientific would be fine, so long as you've got a cash flow, not a cash flow, sorry, I apologize. Okay, we just looked at cash flow, right? As long as you've got a stats mode on your calculator, you're going to be able to calculate these figures. Right, solve for standard deviation. Okay, and the calculator gives you 8.36. Okay, approximately 8. Okay, 24 is theory relating to the correlation coefficient. Okay, that's R. Alright, so R here was given as 0.88. Okay, so obviously there is a positive correlation here. Okay, so option number 1. Okay, now we've got question 25 and question 26. Right, in this particular question, we're looking for what? Bond value. Okay, we're looking at the all-in price. Okay, alright, so we need to draw a timeline for this particular question. Okay, alright, I have looked at this question ahead of time, and I'm going to let you know now before we started that sometimes there's a problem with the question. They're not specific enough in terms of telling you this is semi-annual. Okay, if you use what they've given you in the question, which is per year, which is annually, okay, you're not going to get an option that's there, right? And then I'm going to be choosing none of the above, right? Normally, none of the above isn't the correct answer. It can be though, right? So if you do it annually, you're not going to get an option that's there, right? If you look at the textbook or the study guide rather, okay, the study guide that you've been provided with state that you should assume in general that bonds are going to be paying coupons semi-annual. Okay, that's generally what you're going to be finding in terms of the convention. Okay, what bonds normally offer, okay, are semi-annual interest payments. Right, so if we use that as the convention, as the assumption, okay, as this assumed bond payment, okay, in terms of being semi-annual, you're then going to get one of those options exact. Okay, so that's what I've done to get the right answer. Okay, I've obviously drawn a timeline first. Okay, so I need dates. Remember, settlement date is key, and maturity. Are those dates the same? No, they aren't. Okay, so the maturity date is going to determine when the coupons are going to be paid out. Right, so let's draw. I need the years as well here. Okay. Alright, so if I'm looking at coupon to coupon, okay, and this is obviously my settlement. Okay, so I need H and I need R. Okay, so H here is half yearly, so 184 days. Okay, and then R would be that time frame. Okay, from settlement to the next coupon. Okay, if it's 27 days, it's greater than 10 days, so therefore this is cum interest. Right, so step number one is always to calculate price at the next coupon. Okay, so I need the variables. Future value is 100. N, okay, if I look at number of years, right from here to there, 8 September to 8 March, 2015 to 2045, you need to calculate the number of years. You'll get 29.5 years. Times by 2, because this is semi-annual. Okay, 59.5 years. Right, the I, 8.7% divided by 2. The payment, 10.9 divided by 2. Solve for present value. Right, if you solve for the present value, you're going to get the 123,2369087. Alright, this is cum interest. So add the coupon. Okay, and the coupon here was 10.9 divided by 2, which is 5.45. Alright, so all in is equal to 5.45. Right, and that's the all-in price that I get, okay, having done the calculation. Right, now what do I need to do? I need to obviously take this amount where? Back. Back to where? Back to time 12 August. Okay, settlement date. Alright, so take that amount and move that amount back in time all the way through to the settlement date using fractional compounding. Okay, so future value is obviously this answer over there. Right, and I get that answer exact. Okay, so if I'm looking at my options, I'm obviously going to choose option number 3. Alright, question 26 is asking about the clean price is approximately to the nearest 100,000 in terms of the nominal value. Okay, so before we can work out what it is in terms of its nominal value, we first need the clean price. So let's work out the clean price. All in minus accrued interest gives me clean price. Okay, so I know what the all-in price is. That came from above. Okay, so there's the all-in price. Okay, I just need to minus the accrued interest. Okay, which I actually need to calculate, or do I? No, I don't. I think I remember seeing that. Yes, I do. Okay, there's the clean price, all-in. Sorry, not all-in. Accrued interest. Okay, I've got the all-in. I just worked it out. I've got the accrued interest, and that can calculate. And now I can calculate the clean price. Okay, so negative. Okay, and that's going to give me one, two, three. All right, comma 1, 9. All right, they ask for nominal value here. Okay, so what am I going to do? I'm going to have to multiply by the nominal value. Okay, is calculated by multiplying this by the 870,000, okay, because that's the nominal value of the stock, and they want to know the approximate clean price. Okay, and I get that answer. Right, they wanted to know what the this was a percentage. That was bond pricing convention. Forgot the percentage. Okay, so divide by 100. Okay, that number is very, very, very big. Okay, it's not as big in terms of the working. Right, and I get that 107,812. Okay, so if I round it off to the nearest 100 rand, okay, I'm going to get option 1. Okay, and you can see option 1 is there. There is none of the above. Right, so this option must go with that one. Okay, that all in. Okay, with that clean price. Okay. Alright, question 27. Monthly deposits of 100 each are made into bank account earning interest, 18% compounded monthly. The time that it will take to accumulate 20,000 is given by. Okay, so again, this is mathematics. You're going to have to play around with the equations. First things first is obviously to write down the equation. Okay, they said accumulate to 20,000. Okay, so I'm looking at the future value of an annuity. Okay, so that is the equation for the future value of an annuity. Alright, so I'm going to substitute amounts in. 20,000 my future value. They told me the payments were 100. Okay, then I'm going to have an open bracket, open up another bracket, and I'll have 1 plus the I. What is the I here? The I here was 8% compounded monthly. Alright, so 18 R12 equals 18 divided by 12, which is 1.5. Okay. Alright, so 1 plus 1.5 is 0.15. Okay, to the power n minus 1. Close that bracket. Then divide that by 0.015. Okay, close that bracket. Right, so that's what you've got. Okay, what am I going to do now? I'm going to take amounts to the left and the right. Okay, so this 100 comes to the left. Okay, obviously 20,000 divided by 100, drop 2 zeros. Okay, gives me that. Right, then what do? I take the denominator from the right and I bring that to the left. Okay, so it becomes times. Okay, that gets rid of the denominator. Okay, then I need to obviously take the 1 across, so now this becomes plus 1 on the left. And then I'm left with that. Okay, so now remember I said in a previous video that you need to think of something simple. Okay, so this is what I write down when I have a log-ln type question. Okay, I'm going to need that to determine what the exponent is equal to. Okay, so obviously I have this equation, okay, with n. What is n? N is the exponent. Okay, so the exponent is there. Okay, so the exponent must equal, n must equal, okay, the log, right, of the base. My base in this question would be 1.015, okay, of the answer, which is the 200 times the 1,015, close bracket, plus the 1, close that bracket. Okay. Alright, and then here they've just applied a log or a ln. Okay, so remember with the log rules, if I have this log x, y, that's the same as log y over log x. Okay, where I have the same base. Right, so they've applied the same thing here. Right, so ultimately n would be equal to log, open brackets, all of that, over log 1,015. Okay, or logs or lns. You can obviously substitute a log with a ln. It's just base e. Log with base e. Okay, or log with base 10. Okay, in terms of exponential functions. All right, so that's the final answer that I'm going to be getting. Okay, which is option number 1. Yes, option number 1. Okay. Alright, so very mathematical there. Trying to get the correct answer using a formula. Alright, 28, if the nominal rate is given as that, compounded at every second month, so that's I6, they want to know what the effective interest rate, which is your EFF calculation. Right, so all you're going to have to do is substitute, use the financial calculator, either the conversion function, okay, or the P over Y for the HP, or the X comma Y button for the sharp. Okay, depending on what calculator you've got, you're solving for EFF. Okay, second function EFF on some of the calculators to get the correct answer. Okay, so N here is 6, my I here is 16,5. Solve for EFF. Right, and the calculator will give you 17,6768%. Right, which is option number 4. Okay. Right, question 29. Okay, 29 and 30 relates to this set of data. Okay, age of the machine, the repair costs. Okay, you can see there's X and Y here. 29 is looking for the coefficient of correlation, which is R, and 30 is looking at A and B to get the linear regression equation. Okay, so all you're going to have to do for question 29 and 30, use the stats mode on the calculator, normal or scientific or financial. Okay, those calculators should have a stats mode. Alright, your R comes out to 0.9836, option 2. Okay, and then question 30, A and B. A comes out to 0.23 and B comes out to 1.49. Okay, and remember your equation y equals a plus bx. Alright, so if I'm writing the correct equation, a is 0.23, okay, and b is 1.49. Alright, so 1.49 times x plus that, which is option 3. Option 3 looks good. The A and the BX, yes. Okay, guys. Alright, and that's another past paper complete. Alright, so hopefully with more practice, this is getting easier and easier and easier. It should be. Okay, so in my normal weekly lectures, I obviously take students through the content, the theory. Okay, these videos are purely for you to practice doing more of these calculations. Okay, the easier it gets, obviously, with more practice. Alright, guys, thanks for watching this video. Hope to see you guys again soon. Bye, everyone.